My name is Ishan Mudgal. Today we are going to discuss one of the most important concepts in network theory, which is the transient analysis. Right. Transient is one of the most important concepts if you see through the practical life or through the GATE exam. In GATE exam, you will see every year contain at least one question from this concept. Okay. Now for the practical life, see, there are almost everywhere the real life example for the transient. Let us suppose I am taking one example. When you switch on the AC, tell me what happened. When you switch on the AC, the first thing happen is the voltage fluctuation or the blinking of the voltage. For how much time? For some little time, say 1 second. And after that, what will happen? The AC will start. So for this time, for this 1 second, is our AC in working mode or not? No. The AC is not in a working mode. It comes in a working mode after that fluctuation, after you get a constant voltage. Right. So transient is the state which comes because of the disturbance or changing of load or fluctuation or removal of load, but all this can be happen only in a sudden movement or in a sudden time. So the complete definition of transient is transient state is a state which comes due to the disturbance in the network, and that disturbance can be because of addition of load, decrement of load or switching, but at sudden instant. Okay. So, why this transient occur? See, in transient occur only in a network if you have energy storage elements. For example, inductor and capacitor. Because in transient, actually what will happen? Energy will be transferred from one element to another element. And when the energy transfer has finished, we will got a steady state, which is a state of rest. And in a steady state, actually your working will start. Okay, so in transient what will happen? Energy will transfer. For transferring the energy, there must be some energy storage element, right? So for a transient in a network, in a practical and for a theoretical work, two things must be important. First, that the disturbance can be at a sudden instant, and second, the network must contain some energy storage element. Okay, and that energy storage element can be inductor, capacitor, or a combination of both. Okay, now order of the network. Order of the network tells you how many storage elements are present in a network. For example, first order network. First order means only one energy storage element. It can be either inductor or capacitor. For second order network, it means two energy storage element present in a network. It can be L or L, combination of LC or two capacitors. Okay, so for a transient, energy storage element as well as sudden change in the network must be present. Okay, now what will happen in a transient? Only inductor and capacitors energy will be transferred, right? It means in transient only inductor and capacitor will affect. All other elements like voltage source, resistors will be same. Now we will see how will they affect. Okay, so for your GATE exam, first order network is the most important network. Okay, because 60 to 70% questions come from the first order network and rest from the second order network. There is not the higher level questions, higher order network questions. Okay, so first of all we see how will our inductor and capacitor will react. But before that we will see the timing diagram we will use in a transient. Timing diagram we will use in a transient. See, this is a timing diagram we will use in our transient. Timing diagrams, it start, the point, origin t equal to 0 is the instant at which disturbance occurs suddenly. That t equal to 0 is a disturbance because of the switching or because of the short circuit, open circuit, or addition of some load. Okay, so at t equal to 0, suddenly your behavior of a network is changing. It is the instant of disturbance. 0 plus is a little time or a momentary time after your transient start, and t equal to 0 minus is a momentary time before your transient start. Okay, and t equal to t dash is the time till your transient state present in a network, and after that, if there is not any further disturbance, all you get is steady state. Now see, transient time which is shown by t equal to 0 to t equal to t dash, it is the very small time. Okay, it is in range of microsecond to millisecond in case of DC, and in case of AC the range is picosecond to nanosecond, right? So this little time, for this we have study of the transient, and this little time will study the transient. After that transient state we will get the steady state. So this is a timing diagram we will follow. We will see how our inductor and capacitor will behave at different time instant, at 0 minus, 0 plus, t dash between transient state, and after t dash till infinity. Okay. So first of all, we will take the case of inductor. For inductor at t equal to 0 plus. Okay. Now see, what is the voltage across the inductor? Voltage across inductor is L dit by dt. Okay. This is the voltage across the inductor. Now we have to find out what will happen at t equal to 0 plus. Which means if I am talking about timing diagram, so let us assume I am taking inductor current at t equal to 0 plus is IL 0 plus, and at t equal to 0 minus I am assuming it is IL 0 minus. Okay. Now tell me, what will be the change in time from 0 minus to 0 plus? It will be very low, it will be negligible, which means dt tends to 0, change in time, which means I can write the same equation in this way. This is a change in the inductor current, right? Now dt tends to 0, which means this tends to 0, and we can see that inductor current at 0 plus is equal to inductor current at 0 minus. Inductor current at 0 plus is equal to inductor current at 0 minus, and this is the first most important equation in transient, and this equation can only valid for the inductor, not through any other element. Remember this point, only through inductor current at 0 minus is equal to current at 0 plus. Okay, and why? You have the derivation. Now see, if in a branch current is constant, what does it mean? It means there must be a current source, right? So at t equal to 0 plus, the current is same. So inductor is always or generally change into a current source. What I am saying, that inductor at t equal to 0 plus is change into a, change means it's not physically change. Change means it behave like a current source having magnitude IL 0 plus. Like this. So generally at t equal to 0 plus, inductor will change into a IL 0 plus in a current source. Now case if IL 0 minus is equal to 0 ampere, which means inductor is not initially charged. We can say inductor current is 0 ampere. So IL 0 plus will also equal to 0 ampere. Yes or no? Now in a branch, if current is 0, what does it mean? Open circuit, which means inductor will behave as an open circuit at t equal to 0 plus. So remember this line, that at t equal to 0 plus, inductor generally change into a current source. But if initially inductor is not charged or IL 0 minus is 0 ampere, inductor will change into an open circuit. This you have to remember to solve the question for transient. Okay, so we have seen what will happen at t equal to 0 plus across inductor. Now we will see what will happen at t equal to infinity. Okay, at t equal to infinity. Okay, at t equal to infinity, again we will use the same equation of voltage, that VLT is equal to L dilt by dt. Now, for t tends to infinity, inductor voltage is L. Change in time from 0 to infinity. What is the change in time? Infinity. What is the change in time? Infinity. And 1 upon infinity is how much? 0 volt. So, voltage across inductor at infinity is how much? 0 volt. If across some terminal or branch there is a 0 volt, it means what? Short circuit. It means at t equal to infinity, our inductor will behave like a short circuit, like this, at t equal to infinity. Okay, and one more thing. Infinity is a steady state, and we have seen a timing diagram before t equal to 0, which means 0 minus. It is also a steady state. So both concept is correct for t equal to infinity and t equal to 0 minus. That in both the time instant, our inductor will behave like a short circuit. Correct? Now we will see what will happen in a transient time, which means between t dash and between 0. What will happen to the inductor, or how inductor will behave in this time instant? We will see now, right? So again we are using the same equation, that voltage across inductor is equal to L dilt by dt. Now we can, for finding out in a transient time, we can use two mathematical tools. One is partial differentiation. Second is our Laplace transformation. Okay, we can use these two mathematical tools to solve it. So it's easy to solve your calculation or your question in a Laplace transform. So we will follow the Laplace transformation method. Okay, so can we find out the Laplace transformation of this? And we are assuming there is some initial current in the inductor, or inductor is charged with some initial value. So taking Laplace transform, okay, taking a Laplace transform, it will be VLS L SIS minus IL 0 plus. Okay, why IL 0 plus? Because we are assuming there is some initial current. Okay, now from this, inductor voltage in Laplace form will be like this. Okay, now can we form a network from this KVL equation? Why this is KVL equation? Because here it is a unit of volt, it is a unit of volt, it is unit of volt. Now this has to be the unit of volt to follow this equation. Now see, any value at a particular instant, which means current at 0 plus or 1 second or 2 seconds, is always a constant value. So this is a constant inductor value is a constant, which means this is a constant having magnitude, having dimension of voltage. So can we say that this is an independent voltage source? Right. We can show this term as an independent voltage source. So we will convert this equation into a network, which means there is an inductor in Laplace form SL, and there is a voltage source having magnitude LIL0 plus, and the current flowing is IS, this VLS. Now see carefully, there is a minus sign which is the polarity against the direction of current, which means this will be how? Minus plus. So finally our inductor will behave like this in a transient time, which means t between t dash and 0. Got it? So we have seen at every time instant, or 0 minus 0 plus between transient time and infinity, how will our inductor behave. Now we will see all the same concept in capacitor also. Now for capacitor, what is the equation of current? Equation of current across capacitor is equal to C dvct by dt. Yes or no? Now we are seeing what will happen, or how will our capacitor behave at different time instant. Which means first we will see at 0 plus. Now we are assuming capacitor voltage at 0 plus is Vc 0 plus and it is Vc 0 minus, like this. Okay. Again the change in time is tends to 0. Yes or no? Which means capacitor current multiplied by dt is equal to C dvdt. Yes or no? This is tends to 0. And what is change in voltage across capacitor? It is Vc 0 plus minus Vc 0 minus, and this is 0. And after solving this, we will get Vc capacitor voltage at 0 minus is equal to capacitor voltage at 0 plus, which means this is the second most important equation in your transients. First was inductor current at 0 plus is equal to inductor current at 0 minus, and second, voltage across the capacitor. Okay, always remember only current in inductor and voltage in capacitor. Follow this equation, not any other quantity in any other elements. Now if the voltage is constant, we can say that capacitor behave like a voltage source, which means at t equal to 0 plus, at t equal to 0 plus, capacitor will behave like a voltage source having magnitude Vc 0 plus, like this. Okay, and magnitude is also same. Okay, now again case here, case if Vc 0 minus is equal to 0 volt. This case means if capacitor is initially not charged, which means capacitor voltage will be 0. If voltage is 0, which means what? Open circuit or short circuit? It means short circuit, which means capacitor will behave like a short circuit. Okay, so what will happen? At t equal to 0 plus, capacitor generally change into a voltage source, but if the magnitude of voltage source is 0, it will change into a short circuit or behave like a short circuit. Okay, now we will see at t equal to infinity, which is a steady state. At t tends to infinity, again we will use the same equation, change in time is how much? Correct? dt tends to infinity, which means current through capacitor infinity will be Ct Vc by infinity upon infinity. Yes or no? Now, what is 1 upon infinity? It is 0 amp. 0 current, which means open circuit. So, t equal to 0 plus. T equal to, sorry, not 0 plus, t equal to infinity. T equal to infinity, our capacitor will change into a open circuit. Okay? And also at t equal to 0 minus, because both are the steady state. So, inductor was behaving like a short circuit at steady state. Capacitor is behaving like an open circuit in a steady state. Okay, remember this. Now we will see what will happen in a transient state, which means time is between t dash and 0. What will happen in transient state? Okay, again we will use the same equation. But now we will take Laplace transform of it. Laplace transform. Okay, it will change into a ICS, and we are assuming the capacitor is charged with some voltage Vc0 plus, and it will be S Vcs plus Vc0 plus. Okay, capacitor is initially charged with some voltage. Now, after rearranging the equation, you will see capacitor voltage in Laplace form will be 1 by Cs plus, sorry, here it will be a minus. Here it will be a plus Vc0 plus by S. Okay, this is again the KVL equation. We can again form the network, right? But see here, the sign is plus, so polarity will be reversed compared to your inductor case, which means here it will be a capacitor voltage source plus minus 1 by Cs plus minus Vcs, capacitor current is flowing, ICS, which means in a transient time what will happen? Capacitor will change into its Laplace form in series with some voltage source having value Vc0 plus. If initially capacitor is not charged, what will happen? Vc0 plus will be 0 volt, which means short circuit this branch. So till now we have seen how the inductor and capacitor will behave in a different time instance. Okay, no other element, resistor, voltage source, current source will change in any time instant, only inductor and capacitor. Okay, now I am going to tell you what are the steps to find or solve the transient question. Okay, for any question of transient, if you know the question is of transient, the first step is always say that you have to find capacitor voltage at 0 minus and inductor current at 0 minus. These two voltage you have to find for any question of transient. Okay, and if in the question the values are given, use that value. Okay, and for finding any value in any time instant, you have to draw your network at that time instant. For example, if you want to find a value at 0 plus, any result or any analysis at 0 plus, draw your network at 0 plus. For infinity, draw your network at infinity. For any time transient, draw the Laplace transform of your network. Okay, so first we will see the questions, and through the questions we try to understand how to solve the transient. The first step is to find inductor current or capacitor voltage at 0 minus, and before that there is a shortcut formula also. Current through any branch or any element, let us say current through any element, ID is equal to I infinity minus I0 plus e raised to power minus t by tau, where tau is a time constant and voltage across any element will be V infinity minus V0 plus e raised to power minus t by tau, where tau is again the time constant. See, the limitation of this formula is we can only use this formula in a first order network, not the higher order network. Okay, so now we will solve some question based on this. Okay, let us suppose we have given the source free RL circuit. We have given the source free RL circuit like this, and we have to find the current ID when this switch is thrown at the position B. Okay, in this network we have to find the current ID when a switch from A throws to the position B. Okay, now we will solve it using the shortcut formula. What is the shortcut formula? That ID is equal to I infinity minus I0 plus e raised to power minus t by tau. In this formula, we have to find out three values: current at t tends to infinity, current at 0 plus, and the time constant tau. Okay? So, first of all, we find a current at 0 plus. But always remember, the first step is to find current through inductor at 0 minus. Okay? So, first step, at t equal to 0 minus, the switch is at A, and at t equal to 0 minus, inductor will behave like what? It will behave like a short circuit. And we have to find a current IL 0 minus. Okay? So, IL 0 minus is equal to V by R. Yes or no? Now, we know that IL 0 plus is equal to IL 0 minus, which is equal to V by R. Got it? Now see, for using this formula, we have to find out three values: I0 plus, I infinity and tau. And don't confuse, this is IL 0 plus. Inductor current is 0 plus. And this is a current that we have to find out. Now see, the current which we have to find out, IT, is also passing through the inductor in this question only, right? So we can say I0 plus, we can say that I0 plus is equal to IL 0 plus, because the current is passing through inductor also. It is how much? V by R. Yes or no? I0 plus is how much? V by R. Now we have to find the current at t tends to infinity. Okay? So we will draw our diagram at t tends to infinity. Now tell me, at t tends to infinity, inductor will change into what? Inductor will change into a short circuit, right? And if inductor is changing into a short circuit and the switch is at B, the diagram will be like, this, and we have to find a current at t tends to infinity. Now there's not any other source, no current will be flow. So we can say I infinity is how much? 0 amps. And time constant, there's only one inductor and one resistor. Time constant will be L by R. Now put all the values in above equation. We have I infinity is 0 minus V by R e raised to power minus t L by R. Yes or no? And this gives you the current equal to V by R e raised to power minus RT by L. Now, this is the current equation. Now see, this is an equation of charging or discharging. This is an equation of discharging, which means inductor is in discharging nature. And you can see that initially the inductor is charged to some voltage by flowing the current, and now it is in discharging mode. So guys, you can solve the questions using this formula. And remember, the shortcut formula is applicable only for first order network. Okay? And the network must contain some resistance. Otherwise, what will happen? Time constant will be 0, and then only this formula will not applicable. So solve the transient questions carefully, and the questions are so much easy if you follow the steps. Okay? Thank you, and keep watching. Subscribe our channel.